Imagine peering into the vast expanse of the universe, beyond the gleaming, twinkling stars, to unveil the mysteries of spiral galaxies similar to our own Milky Way. That is precisely what the physics at high angular resolution in nearby galaxies, or PANGs, collaboration achieved. Using the impressive capabilities of the James Webb Space Telescope, they studied 19 nearby galaxies in infrared light. Not simply realms of stars, these galaxies are also home to gas and dust, elements which provide invaluable insights into not only the formation of new stars, but indeed their life cycles. They have revealed that stars are born in dense regions of gas and dust within the galaxy's spiral arms, sculpted by propagating density waves. And these young stars, in their vibrant youth, send out intense radiation and stellar winds impacting the surrounding gas and dust, creating unique structures. A constant dance between creation and decay, a symphony of interstellar proportions. However, there is a fascinating pattern to this star formation. It seems to start at the heart of the galaxies, the core, and cascade outwards along the spiral arms in a silent cosmic wave. And these observations have also hinted at, well, I won't spoil the surprise just yet. You'll have to stick around to find out. What's up, my amazing and curious folks? Ready to unravel the mysteries of the universe together? I'm your guide on this journey, Caesar, and with me is the brilliant and charismatic Sonia, ready to dive deep into the cosmos with us.
Hey there, folks, excited to be here, navigating the cosmic waves with you all.
Don't forget, Curiosity Explorers, to subscribe to the Curiosity Wonderland and hit that bell icon so you never miss a chance to learn something new. Get ready to have your minds expanded. Diving deeper, let's talk about a fundamental rule in astronomy. It all comes down to what we can observe, and that's limited to what our instruments can detect. Most often, we end up focusing on the things that are easiest to see, the brightest, the closest, and those that emit visible light. When we consider galaxies, we usually think about the stars within them. But in reality, there's so much more. Large spiral galaxies like our own Milky Way are not just clusters of stars. They're also home to complex networks of gas and dust, with cavities created by stellar cataclysms. Using the James Webb Space Telescope's incredibly sharp and powerful eyes, the FANG's collaboration has unveiled the life cycles of stars within 19 nearby spiral galaxies. The findings have been nothing short of breathtaking, shedding unprecedented light on the cosmos. And get this, for a long time, whenever we looked at a massive spiral galaxy like the Milky Way, we assumed that the stars we could see lined up with where the mass was. But we've come to learn there's so much more than meets the eye. Remember, in our solar system, it's the sun that outshines them all, making up some 99%.
Whoa, hold on there. Are you saying we've been seeing only a fraction of what's really out there?
Exactly. It's like we've been looking at the universe with one eye closed. But thanks to advancements in technology and these groundbreaking studies, we're now opening both eyes wide. It's a whole new perspective. Stars actually only make up about 2% of a galaxy's total mass. The rest is gas, dust, and plasma, with the majority being dark matter.
Dark matter? The stuff we can't see but know it's there because of its gravitational pull.
That's right. To understand the life cycle of stars, we can't just look at visible light. We need to consider the presence and distribution of all matter, not just the luminous stars.
So it's not just about the shiny things we see in the sky, huh?
Exactly. We also need to understand how gas within the galactic disk behaves, and how it clumps up in arm-like configurations as density waves ripple through it.
Those are the spiral arms of a galaxy, right?
Correct. And we need to understand how waves of star formation occur throughout the galaxy, how gas gets moved around, and even what happens when stars die.
Stars can die?
Indeed, they do. The process of feedback and stellar death, where energetic light, winds, and even shock waves of matter from living and dying stars can impact the matter in the spiral arms and the greater galactic disk.
Wow, there's so much more to galaxies than just pretty twinkling lights.
Absolutely. And all of this is why we have projects like the FANGS program, aiming to image these galaxies in high detail across different wavelengths of light to understand the physics and astrophysics of the processes at play. These 19 galaxies, chosen by the FANG's collaboration, are large and close by. Their position lets us view them in a way we'll never see our own Milky Way.
So, we're getting a perspective that's not possible with our home galaxy.
Exactly, and the James Webb Space Telescope, or JWST, is the tool for the job. It can image these galaxies in both near and mid-infrared light, revealing stars, hot gas, cooler gas, and dusty features.
And what does this infrared light show us?
It reveals amazing details. The dust that forms new stars and lines the arms of spiral galaxies doesn't block the luminous sources in infrared light, but shines brightly itself. And when starlight hits the dust, it heats up and illuminates the spiral arms.
So we're seeing more than just stars?
Absolutely. We can see regions of new star formation and even hints of activity within the galaxy's nucleus, including potentially active supermassive black holes. And little pockets within these galaxies show us places where stellar cataclysms, like supernovae, have blown the dust away.
This is like a whole new look at our universe.
It truly is. The revelations from this research are giving us unprecedented insights into our cosmic neighborhood. Dust in these galaxies is not just a simple component. It could be large grains of material, or heavy molecules such as carbon-rich organic molecules like polycyclic aromatic hydrocarbons.
So this dust is not just ordinary dust, it's more complex?
Absolutely. Wherever dense molecular gas exists, dust will be present. And these spiral arms we've been discussing, they become the regions where that gas and dust are densest.
And what happens when stars are formed in these regions?
When there's dense molecular gas near young stars and star clusters, the dust within that gas gets heated and becomes easy to see with a telescope like the JWST.
So star formation can affect the dust?
Indeed. In fact, if there are too many stars shining for long periods of time, that molecular gas and dust can get evaporated away. And in regions where there's lots of star formation, supernovae and ejecta from young or dying stars, that gas and dust can be blown away from a rather large region, blowing bubbles and creating cavities in that gas and dust.
This sounds like an elaborate cosmic dance.
Absolutely. And all of these features combine to create what we refer to as the dust map of the galaxy. I hope our audience is finding this as fascinating as we are, right? The universe is such a vast and amazing place, full of complexities and wonders that are just waiting to be discovered. I wonder, are there any budding astronomers among our listeners? Do you find this as captivating as we do? Don't forget to hit the like button if you're enjoying the content. We appreciate your support as we journey through the cosmos. By combining this data from the JWST with other instruments that show the positions, populations, and temperatures of stars, hot ionized gas and supernova remnants, we can begin to understand the life cycle of normal matter within these galaxies.
So it's like we're piecing together a puzzle?
Exactly. In the outskirts of these galaxies, diffuse atomic gas moves inwards, becoming denser and forming molecules in the spiral arms. Stars form from the gas and dust, which then heat up the remaining dust and gas, evaporating it and creating huge cavities.
It's like a cosmic assembly line.
It is, and we're learning all sorts of new details about how it happens inside these spiral galaxies. The JWST has allowed us to identify millions of individual stars, even at distances of millions of light years. And we can see two distinct classes of dusty features in mid-infrared light. This actually reminds me of an event recently. I was looking up at the stars with my nephew, and he asked me where all the stars come from. I explained to him about the dust and gas in galaxies forming stars, just like we're talking about right now.
That's so coincidental. Just last week, I was trying to explain to my niece about how stars are born from clouds of dust and gas. She was fascinated by the idea that something as small as a dust particle could eventually become a shining star. It's a reminder of how interconnected everything in our universe really is.
But there's more. The dust also encases stars that are still forming, where gas and dust are feeding the growth of stars and possibly star clusters. When you combine near-infrared and mid-infrared data from JWST, and if you choose, optical data from Hubble and possibly other data as well, you can see evidence for these features side by side.
So we're essentially witnessing the birth and development of stars through this accumulated data.
That's right. We're observing a remarkable story unfold about the life cycle of normal matter and the stars that form within these galaxies. The conventional wisdom was that stars would form continuously along these spiral arms from the galactic center equally. But the data tells a different story. It appears that galaxies grow and star formation propagates from the inside of a galaxy outward. Episodes of star formation begin at the core of a galaxy and spread along the arms of the galaxy thereafter, moving outwards.
That's fascinating. So the stars near the outer edge of the galaxy are younger?
Correct. The farther away a star is from the galaxy's core, the more likely it is to be younger. Near the cores of many of these galaxies, there's an emptiness of gas and dust, and simply a dense bulge of stars, which generally tend to be populations of older stars.
It's like a cosmic timeline, age recorded in the location of stars within the galaxy.
Exactly. And these bright spikes emerging from a galaxy's center are evidence for either a supermassive black hole that's actively feeding at their cores, or alternatively, a series of star clusters that are so bright that the image itself becomes saturated within JWST's detectors. We have a great example of this in the spiral galaxy NGC 1365, which is located 56 million light-years away. JWST has mapped out the intricate dust filament network of this galaxy in exquisite detail. New stars are forming very close to the galactic center itself, as well as along the spiral arms radiating out from it.
And I suppose those great cavities in the dust are evidence of recent star forming and stellar cataclysm episodes?
That's absolutely correct. At the center, there's a bright, spiky feature which suggests the presence of an active supermassive black hole. With the imaging of these 19 Fangs galaxies, we are not just looking at beautiful maps of gas and dust, but we're also seeing millions upon millions of stars imaged and resolved. This allows astronomers to observe stellar populations in spiral galaxies outside our own local group.
So it's giving us a more detailed look at how the stellar life cycle works.
Yes, indeed. We're learning about how gravitational collapse, turbulent flows, and various types of radiation and winds all interact to give rise to stars, star clusters, and non-stellar features within each of these galaxies. And there's more to it. There are also around 100,000 star clusters identified within these 19 galaxies, which is the largest catalog of star clusters ever developed. This data is now accessible to the entire astronomy community, and it could revolutionize how we understand the relationship between stars, gas, dust, and their host galaxies. What is truly amazing is that despite how different these galaxies appear from one another, the same processes are at play within them, and the same conclusions can be drawn from looking at all of them together. When we see these bubbles and cavities in the dust, as well as the filamentary dust network and how it follows and lines the spiral arms, we're probing the star formation cycle on the smallest observed scales ever.
So, essentially we're studying the architectural blueprints of galaxies.
That's a great way to put it. As astronomers measure the spacing between the stellar, gaseous, and dusty features within these galaxies, they're learning how a galaxy's gas and dust are distributed, which provides insights into the processes that shape them. From the supermassive black holes at their cores to the star-forming events, both past and present, that are occurring within these galaxies, we're gaining a better understanding of the inner workings of these celestial bodies. We're also seeing the young populations of new stars and star clusters that have resulted from relatively recent star-forming episodes. All this invaluable information from the Fangs collaboration is shedding new insights on how galaxies grow, how gas and dust are transported, and how star formation shapes the internal structure of these galaxies themselves. In fact, there's enough information encoded in these images that we can expect scientific insights to keep arriving from this study for many years to come. And as we gain more data, we'll keep improving our simulations of individual galaxies, getting a better understanding of how stars, gas, and dust are all interrelated and how they impact the overall galaxy and its evolution. To sum it all up, thanks to the Fangs collaboration and the James Webb Space Telescope, we now have a front row seat to the star-making theaters of spiral galaxies much like our own Milky Way. We've seen how stars are born in dense regions of gas and dust, how their energy impacts their surroundings, and how star formation propagates from the core outwards. We've glimpsed the evidence of supermassive black holes at the center of galaxies and the intricate processes that shape galaxies. This is all a significant step toward understanding our own place in the universe. I guess you could say we're starstruck.
Absolutely, we are. It's been an incredible journey through the cosmos today, folks. There's so much to learn and discover about our universe, and it's a privilege to share that journey with you. If you enjoyed our galactic tour, don't forget to blast that like button and leave a comment. Know someone who's as starstruck as we are? Share this episode with them.
And that's all for today, folks. Keep looking up and keep questioning. You never know what mysteries you might unravel.
Bye for now from Curiosity Wonderland. Stay curious, everyone.
This fascinating information came from the article titled JWST Reveals Spiral Galaxies Life Cycles from Dust to Stars, written by Ethan Siegel and published on Big Think on January 30th, 2024. If you're curious for more, the link is in the video description. Until next time, folks.